Hi everyone, how is it going? And in this video we are going to fine-tune GPT-2 model. We are basically going to train it on conversational AI dataset. So at the end of this video you would be having a chatbot type of GPT-2 model. So basically we are going to use Hugging Face transformers library. In that we have this GPT2LMHeadModel. We are going to fine-tune this model over here, and the dataset we are going to use will be this dataset basically. So the link to this dataset will be in down description, so you can just come in over here and click on raw, and once this new page opens you can just click on anywhere in the blank space, just save the page and make sure you to save the page as JSON. And the main idea is at the end of all of this you should have this chat data.json file over here. As you can see, it is basically a list of dictionaries, and in every dictionary we have the chats. Like as you can see over here, I love iPhone, I just bought new iPhone, and the reply to that is that's good for you, I'm not very into new tech. And you just get the main idea. This is a conversational dataset. We need to filter out this dataset so that we only have this text prompts. Now in order to use this transformers, you have to install transformers. So you just have to say pip install transformers, and once you run this it is going to install the transformers in your computer. And also you have to install pytorch, so just go on run pip install to install the pytorch also. So let's start our main video over here. So first of all, we are going to do the basic stuff with the GPT2LMHeadModel, and then after that we will see how we can fine tune it. So I'm just going to write a main.py, and in this we are going to write our main code basically. So for using that GPT2LMHeadModel, you just have to from transformers import GPT2LMHeadModel, and also we are going to use tokenizer for sure for converting the length of string into tokens, basically integers. So now in order to use the pre-trained GPT2LMHeadModel and tokenizer, what you have to do, you have to say tokenizer is equals to GPT2 tokenizer dot from pre-trained, and you have to pass as a string as this GPT2. And similarly we are going to use this model, so we'll say model is equals to GPT2LM model, and same this GPT2. Now in order to use this model as it is, what you have to do, you have to say model dot generate, and now this generate function is going to take basically the tokens. So for that you have to pass the string from the token. We will say, hey, I was good at basketball, but, and now it is just going to generate the text for us. We can't pass it as it is, we need to convert it into the torch tensor. So we'll say return tensors is equals to pt. Once you do this, we are going to print it on the screen, and as well as this is going to return the dictionary, so we have to unpack the dictionary. So we will now try to run this. In order to run this, you have to say python main.py and make sure your terminal is pointing to the same directory where this main.py is. So we'll just wait and see what do we get. So you see over here it is just returning the token, so we need to use the token to decode this. So we'll one more time we'll say tokenizer dot decode, and we need to access the zeroth from over here since it's a 2D tensor. Let's run this one more time and see what we get. Forgot to save the file, run it one more time. So as you can see over here, it is generating, hey, I was good at basketball, but from after this but it has generated this, I've never played basketball before, so I don't know how to play. So basically currently it is about generating the prompts. Now we need to fine-tune this particular GPT-2 model on to this dataset over here. Now first what you have to do in order to fine-tune this model, you have to have a dataset class. It is not necessary, but you are going to see that the things will going to get much manageable when we create a dataset class. So let's do that, and you will get understanding why we need to do that. So I'm just going to create a chat data.py. now in this we are going to define our class for chat data class. Now it is going to extend from or inherit from the dataset. For now I'm just going to say pass, so we need to import it. So now in order to import, we are going to say from torch.utils. It's I guess data import data set. Yes, it is. Now in this data set you have to basically define some functions, since this is a abstract class. Now in this you have to define first of all init, and of course it is going to take the self, and for now let's just pass. And other you have to pass is I'm just going to open the documentation because I don't remember it. So I'll say torch.utils.data.dataset. Yes, you have to basically underscore length and get item. So length from self and get item. And idx. So basically inside this init we are going to initialize all the variables, data stuff and everything, and inside this length what we are going to return is the length of our data set, and inside this get item we are going to return the particular item situated at that particular index. So it's just that thing. Now over here we are going to get the path, which will be of kind of string. Now once we have the path, which is this chat data.json file path, we are going to read the JSON from there. So I'm just going to say self.data is equals to I need to import JSON also, so JSON, and I'll say JSON.loads, and I have to open this file from this path as a read mode. And once you run this, basically you are going to get a list of this data. Now we are going to iterate inside this data. We are going to get the dictionary, right? So I'll say for I in self.data. As you can see, if we iterate, we are going to get the dictionary, and from this dictionary I want to access this dialog, and again in this dialog it is a list. So I'm going to say for j in, since I is a dictionary, I'm going to target this dialog, and inside this j, so now j will be a list of this dictionary once again, but from this dictionary for every instance of j I want to access this text. So this text I'm going to append into a list. I'm going to say x, and I'm going to say self.x.append j text. That's all. Now one more thing I'm going to take from this is tokenizer. So in order to convert the strings, as you have already seen, in order to make the prediction we need to convert this string into the token by using the tokenizer. That's for sure. After that, once we have the tokenizer, once we have all the prompts in our self.x, I'm just going to pass it from the tokenizer. So I'll just say self.x encoded tokenizer, and I'm just going to pass this self.x, and now in this I need to pad this basically. So I'll just make this truncation equal to true. Other than that, I'll make the padding also equal to true. I guess that's enough. Okay, so I guess this is enough. One more thing I would like to show you over here. Let me just make it first of all. So I'll just import from transformers, import, and I'll say tokenizer is equals to gpt2 tokenizer from. Now if you see that if I pass basically the string from this tokenizer, I'm going to get a dictionary of input IDs and attention mask. So I'm just going to get the input IDs. Self dot input IDs is equals to self dot x encoded input IDs, and similarly I'm just going to get the attention mask also. I'll say attention mask and attention mask. Now what I want to do is basically, as you can see, currently I'm going to have this thing over here, right? What I want to do is first of all have the start of string token over here and end of string token over here, in order to tell our chatbot that this is the start of string and this is the end of string, just like that. Now after that, I'm going to have a bot reply for this. So basically this will be my prompt, what I'm going to provide to the chatbot, and in reply what I am expecting from the model is the reply which will be the just next to it, which is this basically, just like that. So I need to take this string and I need to pre-process that everything and just append as these tokens and this prompt or reply from the chatbot. So how can we do that? Basically, once this all is appended, I'll just say for I in self.x, for I and idx in self.x, I'm just going to enumerate basically. Now what I'm going to say is self.x at that idx will be equal to start of string plus I plus bot reply to this, and then the next one, so I'll say self dot xi plus 1, and after that the end of string, so I'll just say end of string, just like that. Now this is going to produce error for the last sample since there will be no I plus 1, so I'm just going to escape from this with the easiest solution. I'll just say try and accept, and I'm just going to break from this loop. I'll just make a print statement over here just to see if everything is fine. Yeah, everything is fine up till over here. Now in this length, what I'm going to return will be the length of self.x, which will be the length of our data. Since the last one is now of no use, so I'll just say self.x is equals to self.x take everything up to -1. So the last one is of no use. I'm just going to return over here. Now inside this get item, I want to return the tuple of the attention mask and my actual response. So I'll just say self dot input IDs of that IDX and self dot attention mask of that IDX basically. So this is our chat class. So this is our chat data class. Now I'm going to import this chat data class from this. So I'll just say from chat data import chat data, and let's get rid of this and initialize our chat data class. I'm going to pass the path of this chat data object, so I'll just say chat data.json since it's in the same directory, and other thing it need is the tokenizer, so I'll just pass this tokenizer over here. Now some things I need to explain to you before starting getting inside running this program. It is basically this tokenizer doesn't know this start of string, basically this bot token and end of string token, and also it doesn't know the padding token. So we need to tell this tokenizer that this token is that and this token is that. So I need to do is tokenizer dot add special tokens, and inside this you have to pass it as a dictionary. First will be a pad token, so the pad token is going to be basically pad, and other thing we need to pass is start of string and end of string. So beginning of string token and end of string token, and it is start of string, end of string. That's all. Other than that we need to tell it this is a bot token also. So since bot is not a special token, so we need to say add tokens and pass it as a list, this bot over here. Okay, everything looks fine. Now if we initiate this we should get something, so I'll just try to run this and see python main.py. so inside this init we should see this print statement if everything is fine. We got error. It says the JSON object must be string byte, a byte array. Inside this chat data JSON.load. Yeah, we have to use load function instead of loads. I guess that's the problem. Let's run this one more time. Yeah, we got I love iPhone. I just bought a new iPhone. There is something wrong. Actually here will be IDX instead of I. Let's try this one more time. Yeah, we got it. Start of string I love iPhone. I just bought new iPhone, and the bot reply to this is that's good for you. I'm not very into tech, and just end of string. Everything is working as expected. Now what we need to do is train our model. Now in order to train our model we need to set a parameter model.train. We need to get the optimizer, so I'll just say from torch torch.optim import, let's just use Adam optimizer. Let's define this optim over here. This will be Adam, and it will going to take the model parameter, so model dot parameters, like that. Other than that, yeah, one more thing you have to do. This is a pre-trained model on the pre-trained GPT2 tokenizer. Now since we have made changes inside the tokenizer, we have added the special tokens and added this bot token. We need to tell this model that we have made the changes. So in order to tell that, what you can do is model.resize token embeddings, and you just have to pass the length of new tokenizer. So what is the new length of tokenizer? You can just pass it like that. We have everything. We have the optimizer. Let's just define our train function basically. So inside this train function, what we are going to have is the data, chat data, which is the object of the class which we have already defined, the model, and the optimizer. Yes, that's all for now. Now let's just define the epochs. So I'll just going to train for 10 epochs. After that, I'll say for I in range epochs. Now I need to get the data in the batch form, but this chat data class is just going to return me a single instance. So for that, there is a class inside the torch once again. So just torch.utils.data import dataloader, and what you can do is come in over here. I can just say chat data is equals to data loader and pass this chat data, and over here you are going to get option of batch size. So for batch size, we can for now let's say 64 batch size. Now this chat data is going to return us the batch of data instead of returning just a single sample. So I'll say for X and attention, I'll say A in chat data. So how do I know that it is going to return to X and A? Since over here we have defined get item, and this get item is returning the tuple, and we are just unpacking our tuple over here, which is X and A. Now once we have this, we are going to use the model, and inside this model I'm going to pass X as an input, then attention mask as A, and then labels will be X once again. I just come to it, just wait a minute, and it is going to return the loss. So we'll say loss is equals to that. So why we basically set X as the labels and set X as the input? So if you just get back to our GPT2LMHeadModel over here, you are going to see that they have defined the labels just over here. Just give me a second. Yeah, labels over here, they are saying that labels for language modeling, note that labels are shifted inside the model. That is, your label is going to be equal to input IDs. So basically it is just shifted one step forward. So that makes sense that we have to pass X as the labels also and X as the input IDs also. Now we have the optimizer. We'll say optim.0 grade. We'll just make the gradient 0 just like that, and after that we are going to say loss.backward and then optim.step. Okay, looks fine. Let's just use tqdm in order to see the progress. Just like still over here everything looks fine. Let's just define one more function for making the inference. Let's just do one thing, define the inference over here. Now in order to save your model, your progress basically, let's just do one thing. After every epoch I'm going to save the model. So I'll just say torch.save and model.import torch, model.state dictionary, and the name will be model state.pt. Okay, looks fine to me. Now for making the inference, basically let's just define the function infer basically mean making the predictions. So it is going to take the input, and first we need to do this all the steps which we have already understand in the beginning of the video. First we need to use the tokenizer. So we'll say tokens is equals to, let's just say input is equals to tokenizer and input. Before that we need to pre-process it, so you know we have to follow this same structure. I'll just copy it, paste it over here, start of string input, and instead of bot this time we are just going to leave it over here since we are expecting our model to generate the string after bot. Now once we have this over here, I guess we can get the output. We can see model dot, this time we are going to use the generate function as we have used in the beginning of the video to generate the prompt. We'll say model.generate, and it is going to take this input, unpack this, the attention mask as well as the input IDs. Now we are going to decode this output. We can say output is equals to tokenizer.decode output 0 and return this output. Yeah, everything looks good. Let's just do one thing. Since my laptop is very small for all this to train, since the data is also so huge, you can already see there is a lot of data. I'm going to use Google Colab for that. So let's just go back to over here. I'm just going to create a new notebook, then I'll just get back to you. Okay, I'm going to connect, and in this runtime I'm going to change my runtime to GPU for faster training. And inside this file I need to upload this data.json file, so it's in my desktop over here, and this is the file chatdata.json, and hit OK. Now let's start importing our code. First of all, I'm going to import my class, so I'll just do this over here. I'm going to run it. Now let's import our main.py, copy and import it. Okay, if you are getting error, which definitely you are going to get, we need to import the install the transformers. So we'll say pip install transformers. One more thing I forgot to do is to mount this model and all the data to the CUDA device. So I need to define first of all the line for defining the device. So I'll say device is equals to CUDA if torch dot CUDA dot is available. So I have just copied the line so that I don't have to write it. Just set the device as CUDA if CUDA is available, set the device as MPS if it is basically for MacBook with M1 chips, if MPS available, else set the CPU. Now I need to say model is equals to model dot to device, as well as while training over here I need to set them also to CUDA. So I'll say x dot to device, and similarly a dot to device. Let's run this one more time. Also I need to copy the path of this chat JSON and replace this where I was instantiating my chat data class. That's all. Let us just try to run this and see if it works or not. Okay, we got error. Yeah, obviously we have to remove it. Let's run this one more time. Okay, it is downloading the models and libraries, so let's just wait. Done. Now we just need to call this train function. So let's just say train, pass the model. What was that? Let me just double check it. Chat data model and optimizer. So just say chat data model and optimizer. Let's run this and hopefully it should work. We got error which is module is not callable. Yeah, basically it's not like that. It is tqdm.tqdm. List object has no attribute 2. Why is that? We need to convert it. How's that possible, since I have set the tokenizer? Yeah, we need to set over here return tensors is equals to pt. Since it is just returning a normal list, so we want it to return the tensor, so we need to run it one more time and hopefully this time it should run. Okay, there is a lot of data. We need to make some trade-offs over here. Instead of using all the data, what I am going to do is use first 1000, let's just say 3000 samples. It's still out of memory. How's that possible? I think we need to restart our runtime. So I'll say restart runtime. Okay, now the GPU is released. Now try to run it one more time and hopefully it should run. Okay, so basically the problem was what I did is set the max length as 40 and set the padding as max length. I guess the problem was that there was a longest sequence. So what tokenizer do, it just take the max length from all the items you are passing over here and just make them pad to that length. So I just limited it to length 40. So I guess that solved the problem. Now we'll just wait for it to at least at least 6 epochs and we will see the result. Is not consuming much memory over here, so I guess we can change the dataset also at least about 5,000 samples, so we'll have to see that also. I'm just going to stop it for 6 epochs and try to infer and see how it works. I need to print this also, and the error is basically has no attribute shape. Yeah, it's the same error. Inside this infer, I'm sending this over here. I need to set return tensors is equal to pt. I'm just going to cut out this infer function from over here and define this infer function below it over here, and just try to run this one more time. Okay, it should be on the same device obviously. Okay, I'll say x is equals to input IDs and a is equals to input attention mask, and we'll just say to device and to device. Let's run this one more time. Okay, actually this a and attention mask is equals to a. It should work out. Yes, it is working, and the bot replied with hi. So I'm just going to automate it. I'll just say input is equals to input, and I'll just set input is equals to this while true, and I'm just going to print infer input. Okay, I guess that's enough. Now let's try to run it, and it should be ready now. I'll send hi, and we got I'm not given end of string, that's not good. Hello, we got I'm good, how are you, I'm not sure to be, what are you doing, I'm not sure to be good. So let's just do one thing. It is working as we expect it to. Let's just do one thing, increase the data set a little bit. I'm just going to make it 5,000 samples, and other than that let's just try to increase the epochs to at least 12. Also, one thing I forgot is to set the learning rate over here, so I'm going to set LR is equals to 1e, let's say -3. How after that what I want to do inside this train, I want to infer. So I'll say once the epoch is done, I'm just going to infer hello, how are you, just to assess the model. So let's just run this. Now we'll just have to wait and see how it performs. I'm going to stop it because inside this train I forgot to print. Let's run this one more time. What I could have really done is take out this train function. Now we are going to let's just leave it and paste this train function over here. The first epoch has passed and we got the worst reply we could ever get. Let's just wait for it and see. Okay, 3 epochs have passed and we got a reply, I'm a huge gamer. Not good, but at least the grammar and everything is fine. Let's wait for it. Okay, after 4th epoch we got at least a good response, which is hi. Let's just wait. I'm getting a feeling that it will going to perform better. Yeah, this is really good. So I'm going to stop it over here at this 5th epoch and try to make some responses. So over here we got really good response. Let's try to run this and see. So if I say hi, that's not good, I'm a huge gamer. Hello, I'm not sure what you mean, I'm a very experienced person. Let's say how are you, I like to play games and I like to play video games. That's not good. What is your name, I'm not sure, I'm very experienced. That's not good. Let's just keep on training it. So train it for more epochs. Okay, let's try to stop this right over here and try to make some predictions. We got hi, how are you, We got how old are you? I am fine. How about you? I'm fine. How are you doing? Do you love books? I love it. I have a new library at home. Okay, that's good. Which books you love? I read in English. Okay, so you can see that it is producing pretty good responses, considering the amount of data we trained on and the amount of epochs. There is a lot of scope in improvement of this particular chatbot. So what I will basically do, write all this code in down description. There will be a GitHub link. Feel free to contribute to it and make the changes to the code, and we can just make this a better chatbot. Let's just proceed into this and try to see what better do we get. Let's say, do you like coding? I like code and I love it. Which coding language you like most? I'm graduate. That doesn't make sense. I say I want to marry you. Okay, he sent K, just K. I'll say, what is your hobbies? I like to read, watch movies. Okay. I hate you. What do we get? Nothing. I need some money. Do you have it? Can you give me some money? I have no idea. I'm more of a cat person. What can we ask it? What is your name? I'm not sure. I'm a very experienced person. Okay, what do you do for living? I like to read books and watch movies. Okay, I'm going to just stop this video over here. In case of replies, I'll just going to go on and will never end. Basically, all the code will be in down description. If you want to contribute to this code, I'm open to it. And if you want to run this code, again, this is in down description. That's open source. I'll just stop this video right over here. If you have any queries, you can ask them in down comment section. That's all for this video. It's already been how long? 1 hour. Actually there will be a lot of trimming since you see the training part and a lot of stuff. So I'll just end this video right over here. Till then, goodbye and keep coding, and we'll catch you later.